meet the partners from West Africa participating in this workshop. As Abebe pointed out, we have made significant strides in overcoming the issue of maize lethal necrosis and confining it at the present to the 5 or 6 countries in Eastern Africa, especially Kenya, Tanzania, Uganda, Rwanda, Ethiopia, and there are also reports from DRC and unconfirmed reports in South Sudan and Burundi. But over the last 2 to 3 years, intensive efforts have been launched by CIMIT in order to prevent the spread of maize lethal necrosis to the major maize growing countries in Southern Africa, as well as in West Africa in partnership with IATA. These efforts are so far bearing fruits in the sense that we have not heard any fresh incidents of maize lethal necrosis after 2014 when it was last reported in Ethiopia. So last 3 years things have been quite stable, and we would hope that the disease would not only be limited to Eastern Africa but also would be slowly, the impact of the disease would be minimized even in those endemic countries in Eastern Africa. Tremendous strides have been made in terms of breeding for MLN resistance. I will touch upon that in a more detailed manner in my subsequent presentation. But not just maize lethal necrosis, but now there is a compounding problem of the Falami worm, as Dr. Abebe Menkir has pointed out. This requires partnerships. There is no way any organization can deal with this complex challenge of Falami worm without strong support from the national governments and the local organizations, including many of you who are sitting here. You all have to play a tremendous role in this fight against Falami worm, which is a much more serious concern at present compared to maize lethal necrosis even. This is now reported in 28 countries across Africa, and further reports are, confirmations are awaited from 8 more countries where the incidence was informally noticed. So all in all, 36 countries in Sub-Saharan Africa. That's a very rapid spread since January 2016, when the IATA team first confirmed the presence of Spodoptera frugipada in Nigeria, and subsequently another introduction in Sao Tome Principe. So there is a tremendous challenge ahead of all of us. We require more intensive partnerships, stronger commitment, and a lot of energy from everyone concerned in order to fight this major challenge to the food security and livelihoods of millions of people who depend on maize for their livelihoods in Sub-Saharan Africa. So with that, thanks a lot for joining us for this very important workshop. Thanks a lot, Lava, for your organization of this, and the support from IATA colleagues is immensely appreciated. So we look forward to a very productive discussion today. Thank you.
Thank you all for this welcome remarks and also setting the scene for our workshop. Now, very quickly, I just give the scope of the workshop, why we are here today. We already have both Dr. Abebe and Prasanna has indicated the importance of the emerging diseases to maize. Maize lethal necrosis is by now it is almost 6-7 years in Africa that we are battling this disease. In West Africa, we don't know much about it. We keep hearing, and those who visit meetings or been to East Africa, they have seen the devastation. There is a program currently ongoing. There are multiple programs. There is one particular project which is ongoing, which links the bridges, which actually connects the programs that are happening in Eastern Africa with that of West Africa, with the primary purpose of channeling the outputs for management so that the lessons can be taken, the technologies can be taken from there and then adopted here and be ready both to stop as well as in case if accidentally disease get introduced, we are empowered to fight the disease out. So this is a kind of an opportune time to share the success stories and also to challenge ourselves to see how we would like to frame and prepare ourselves to adopt these technologies that are available for us to not only deal with MLN, but also with other emerging pests and diseases. We already, Nigerian community, fraternity already know the impact of the fall armyworm since 2 years. I just thought with this nice picture, it's a banana, not maize. This is a very picturesque setting in Puerto Rico. Puerto Rico, one of the major export crops is banana. They export for revenue. And this is the most latest picture. Almost 90 to 100% of the agriculture was destroyed by one hurricane. Just in 1 week, the country has lost complete production. And those who are familiar with banana, it's a kind of perennial crop. It's not something you can just establish and anticipate something happen in 6 months, 3 years. So it's a complete shock for the country, and they have no backup plan. There is no, I mean, you can't expect, devastations can happen and you expect it to happen here and there, but not the whole country. But this is, I took this example. This can happen, and Puerto Rico, if you take the size of Puerto Rico, it may be a state in Nigeria, slightly bigger than Niger state. Okay, it can happen that an outbreak of this magnitude can hit a state in Nigeria, and then overnight farmers can lose. And this is not a hypothetical scenario. We have experienced this twice since last 2 years. Once, Tuta absoluta, which came in and wiped out in just 2-3 weeks, the entire tomato production was gone. And then the fall armyworm in the same year. So these are not hypothetical scenarios. Some calamities like the situation in Puerto Rico may not be easy to manage because this is beyond the human reach. But then there are some we can fight better, okay? Can you guess what is the crop here? Wild guess. Maize. This is maize in Babati district in Tanzania. I took this picture from a high elevation. If you go in a major maize season, the only crop you see to the far reach is maize. No, I don't need light. Okay. It's just maize, 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 and maize. It's amazing. It's a beautiful scene if you go on the cropping season. It looks fantastic. It's just like a sea of green maize. And where there is no maize, in a very dry areas, the only other crop you see is pigeon pea. It's a fantastic setting for maize. And the farmers one day woke up. It did not happen like in Puerto Rico. It happened in a course of a season. Within a season, they lost much of the maize production with this disease. Initially, they thought there's some kind of drought effect or something because the plants very quickly developed necrosis and then they collapsed. They all look pale, and the spread of the disease is so fast that there is very little time for recovery. Okay, now the plants that get affected very early, they die prematurely. And the studies done so far by colleagues from CEMIT has shown that in East Africa, once the MLN get into the field, there is a loss of 30 to 70%, depending on the stage of infection, or even 100%. So whatever the yield that comes out is actually not usable. So the 2012 outbreak in Kenya alone was estimated to have cost 52 million worth of product loss. Almost all lines are susceptible. And this is just a closer look. Even if when there is a yield, the cobs are not fully formed. And quite often, even the leaves are not, you cannot feed these leaves to cattle because there's plenty of fungi which cause toxic metabolites which can be harmful to the livestock. So the destruction is complete as a consequence of this infection. So this is just to show, even if there is a little product that comes because of late infection, they are highly susceptible to fungal infection. So literally, you will not get anything which is useful once the plant get infected or field get affected by the maize lethal necrosis. Until before this disease, the only virus disease known on maize is maize streak and maize mosaic. And these are kept under control. Maize streak was a very important disease, but thanks to excellent work by IIT and partners, we have resistant varieties, and the disease is in check. We cannot eradicate the virus, but this is kept in check. So this new disease came into Africa, the first recognized in Kenya in 2011. Most likely, it may be there a bit early, but the first record was officially in 2011, reported by the team, the first reporting team here, Dr. Anne Van Guy and the PEG, and also colleagues from CEMET. They are all here in this room, and they are actually gaining experience along with this epidemic in Africa. The unique nature of this disease is a combination of two viruses. One virus which is already known to present in Africa, it is called sugarcane mosaic, and there are other viruses which are transmitted by aphids. And the second virus, which is actually responsible for the disease, is the maize chlorotic mottle, which was introduced from elsewhere. It was never known to occur in the continent. But the vectors for this virus, thrips, they're all over, everywhere. Wherever you see maize, thrips are present. So maize is present, thrips are present. The moment you introduce maize chlorotic mottle, it spreads like a wildfire. So that's a simple rule. Each of it can cause a disease on its own, but when they occur together, the devastation is much more rapid. Another significant feature, which is much more worrying for the region surrounding these countries which are affected by the disease, is seed transmission. If the seed is accidentally moved from affected regions, the disease can spread. So this knowledge actually helped to contain this virus successfully in East Africa. The moment they realized seed transmission is the main culprit for regional spread, with the strict action taken in East Africa has prevented its rapid expansion. But the disease, where it is established, is still being battled for containment. I just like to show this map, how this disease, or the virus, has expanded, just as a reminder that we cannot be complacent, assuming that East Africa is too far from us. The maize chlorotic mottle, the causal agent, was first recorded in 1974 from Peru. Subsequently in USA, Mexico. It's basically the virus that is present in Latin America. And recently there was also reports from other countries. But it jumped into Asia in 2004. It's very likely that it may be there before, but the first record was in 2004 from Thailand, and then came to China. In all these places, the epidemics were not that devastating for one or other reason, whether the thrips are not that frequent, or there are the gaps between the cropping cycles. For one or other reason, it did not make into the headlines, like in Africa. The first major epidemic in Eastern Africa was in 2012, and immediately it's all over the place. The major epidemics were recorded so far only in Eastern Africa and in Kansas State in USA. Okay? So within Africa, the official reports, these are the timelines. You can see, how rapidly it has spread, and we can't underestimate its potential to move further. And Dr. Prasanna has just highlighted about this armyworm, first recorded in Nigeria here, but it may have been already present in other countries simultaneously, but until we saw the fire, we did not recognize that there is another species of armyworm affecting maize. So these diseases can suddenly, even if they're lurking low when the environment is appropriate, they can become epidemic beyond our control in no time. So that's the background, just a reminder that things can happen very fast, and then it leaves very little room for reaction. Therefore, preparedness is very, very important. This workshop is all about learning from MLN management efforts in East Africa. Excellent progress has been made since the outbreak. First, in mapping the disease distribution so that we know how to contain it, and the tools for diagnostics to detect the virus both in plant and seed, methods for surveillance, and also some innovative tools based on ICT technologies. And very good progress has been made in breeding for resistance, and some varieties have been already released. And technology is not alone. And the success, we cannot call success right away, but I think it's a success story in a number of ways in East Africa, the way the various stakeholders come together to the fight against MLN is also backed by excellent policy support from the government. There was very stringent regulations established and enforced, especially on the seed movement between the countries. That played a very important role in restricting the disease to those countries that were affected. So this workshop, we are going to learn very quickly from the overview presentations, and then we brainstorm how are we going to plan for ourselves. Okay, there are also IPM and other issues, plant health and seed health. So the purpose of and objective of the workshop is to raise awareness about the status of maize lethal necrosis and how far we are in terms of containing this problem. And then we can prioritize our actions here. It's a short time, but we have done this exercise a couple of times. There was a workshop in East Africa in 2015, and again there was a very recent workshop organized by FAO in Accra. So there is a preparedness. But now we need to bring those strategies with this technological inputs, the tools and the knowledge that we have in better managing these problems. So the workshop format is very simple. We have just two overview presentations to be given by both, one by Dr. Abebe Menkere about the maize in Western Africa, and then one by Dr. Prasanna on the status of MLN management in Eastern Africa. And then we take a break, and then we come and form 3 groups, and each group would take 3 topics. Quarantine monitoring, this is very, very important. The responsibility or the main goal of the quarantine monitoring is to make sure that the disease doesn't spread into West Africa. And the second group would mainly look into the safe production of maize seed. Okay, this is mainly the domestic seed regulations and how do we enforce good production practices in seed production fields. And the third aspect is about the preventive breeding, which is very, very important in terms of our preparedness. And in the afternoon, we'll take some time off to visit our research facilities. What do we expect? Some kind of a draft plans and needs to stop pest and disease entry, okay? And in case there is any outbreak, what is the best way to stop and contain and eradicate as quickly as possible? And if it is unmanageable, how to limit the spread. So these are the 3 plans that we expect, and I think that is possible. So with this, I stop, and then I would ask some of our partners to convey what do they think that we should expect from this workshop, from their own perspective. Is that okay? Right. So I would request Dr. Vincent Isgbe, the Coordinating Director of National Agriculture Quarantine Services, to briefly tell us what is his expectation.
Dr. Lava, thank you for your elaborate presentation and setting the pace for us to begin the discussion. First and foremost, let me begin by thanking IITA for the wonderful partnership that we've always had, and I believe that there are better days ahead, in trying to solve issues of agriculture to the benefit of our country. It's been a very wonderful partnership, and I want to thank the management of IITA for that. Here too, I've seen so many collaborative partners here too. I believe that together we achieve the success, I mean, the main purpose objective of this workshop. First of all, our expectation, one, is the need to create more awareness. The IT have successfully started this project, and I believe that in our various workplaces, if we can highlight this to our principals, as the case may be, for them to draw the attention of government organizations to the need to combat and control maize lethal necrosis. Why do I say so? Maize is a staple in our sub-region, maize, cassava. We can do without rice, we can do without other things, but for maize and cassava, there's nothing much we can do. It's our staple. So anything that affects maize and cassava should be of very great concern to us. And since we're talking about maize lethal necrosis, is something we need to take serious. More so that we are just recovering, or do I say we are attempting to control armyworm. It's like maize is unfortunate to be attacked by two major diseases. You know, the armyworm and then the maize lethal necrosis. So we need to ensure that we pass the messages across wide so that we can sit up and do exactly what we are supposed to do, either as researchers, as planners, as quarantine officers, as plant pathologists, or as people who are involved in the maize value chain. The second area of my expectation is we need to train personnel, staff, for the identification, control, and management of the maize lethal necrosis in the areas of laboratory training analysis, in the area of quarantine personnel along the border post and border post management. We need to have effective control of the import and export restriction. If we know we have the disease, we have the moral obligation not to export maize, to other countries. And if we are importing, we need to do a double check to ensure that we don't import maize from any country that we suspect to have the disease, or that is in the possible line of transmission based on the studies that we know or we have concerning the movement of maize lethal necrosis. And again, we need to double check on our vector control and ensure that our scientists, all the vectors that are involved in the possible control of armyworm, we check them out in our various countries. The third area I want to discuss, I just have 4 minutes according to the program, is we need collaborative border control in the sub-region through the national plant protection officers and the regional plant protection officers, as the case may be. There's this organization by the IPPC that every country has a national plant protection officer, and in the region, we have the regional plant protection officer. These are persons that should be in top form concerning knowledge spread and information of these diseases. So I think the various national plant protection officers that are here or that are in the sub-region should get to talk with their partners across Africa so that we have a consensus of opinion and action plan on how to do that. Last but not the least is collaboration amongst all of us who are here. Information sharing. If we know what is happening, as harmless as it could seem to be, if we can network and plan, it will help us a lot in trying to pass critical information. I think at this stage it will not be too good if we say, well, I'm not too sure of this, let me wait until I confirm. No, I would rather suggest that no matter how invaluable that information is, let's share. Somebody somewhere will find that information valuable to work on and come up with something that could be beneficial to all of us. Within the limits of the 4 minutes that I have, I think I have concluded. Thank you very much.
Thank you very much, Dr. Esukbai. These are well noted. And now I request Dr. Ojo, the Director General of National Agriculture Seeds Council, Nigeria.
Yeah, thank you very much, Dr. Lava Kumar. I want to thank IITA for collaboration and cooperation. We are very happy to actually be here because we are part of the workshop that took place in Kenya 2015, and we saw exactly what happened over there. From the seed sector, we shall actually properly inform all the operators in the seed industry, because this is actually very, very important, because a lot of them are actually producing maize. They must actually know exactly what is happening. We all know what is happening with fall armyworms in this country and the damage, the extensive damage it has done. If you come to our premises last year, it was so terrible, and it spread even from the southwest to other parts of this country. So advocacy and training, particularly the seedsmen, is actually very important, and we will not waste time in doing this. We will call the seed companies together. I think we are going to do it in conjunction with IITA, because this is very important. On importation, we will ensure that we prevent seed importation from countries that are endemic, so that we don't further expose our country to some of these problems. I want to thank you. Thank you very much.
Thank you very much for the brief and very concise points on the actions that would be taken by the NASC in making sure that we don't have MLN here. I would request the counterpart from Ghana, Dr. Eric.
Thank you very much, and good morning again. We are very grateful to be invited to this important MLND workshop. Recently, somebody called or likened MLN to Ebola, said Ebola of maize. And that really made us very, very worried. Because if we think about Ebola and it is being related to maize, then that's a very serious thing for us. This is also because we all know the importance of maize in our country's diets. It's a staple for us, and also it's an income generating for farmers. In the past, we have faced quite some maize diseases, and the one that comes to mind, which was serious, was the maize streak. And for some years now, we haven't had any problem, and I think Lava has mentioned the efforts that research had put into it. So now coming to realize that there is even a more serious virus, that gives us more to worry. And so immediately we got wind of this. We have started some sensitization programs. And recently, as mentioned by Lava, with the support of FAO and others, a sensitization workshop was organized in Accra. We also did create an alert among quarantine officers to look at maize that is coming from East Africa. We do not know whether the MLN is in Ghana already or not, but we said that any maize that is coming from East Africa must have a certificate that shows that it didn't come with MLN. So this is something that we have started. We expect from this workshop that a lot of experience will be shared, and so that we can take some along with us. One of the major issues we have is that we are not ready if there is any MLN outbreak in Ghana, for instance. So we don't have laboratory setups that can deal with that. So that's something that we are looking forward to. And especially with training of the laboratory staff, so that we'll be able to diagnose and make analysis. So for us, these are very critical. We are also happy that there will be a discussion on the fall armyworm, because we have had our share this year so much, and all efforts have been put by our ministry to ensure that this fall armyworm is controlled effectively. Thank you very much.
Thank you, Dr. Eric. Yeah, these are, I think, what we are doing for MLN outside the endemic area is mainly the messaging and advocacy. And I think thanks to this ongoing project, we are at least trying to build the capacity in Nigeria. But we need to definitely expand these efforts to other regions and other countries so that all the quarantine agencies and seed certification organizations will have good facilities and capability to do the right things. And such facilities not only impart the MLN efforts, but also other pests and diseases. So I think this is very, very important. But how to do it is a big challenge. We'll discuss that. I think with that now, I would request Dr. Abebe to present, give an update on the maize in West Africa, maize improvement efforts in West Africa.
I would like to make a very brief introduction about maize in West and Central Africa to highlight, what the extent of the level, increase in terms of production and area coverage, and how the production system could be a breeding ground, for some of these emerging pests and diseases. In IIT, we have a multidisciplinary team which involves breeders, agronomists, weed scientists, and pathologists, and molecular geneticists, and economists, and also food system specialists working on maize improvement. Maize, as you all know, is a staple food crop in West and Central Africa, accounting for 22 to 70% of the total cereal production in 8 countries in the sub-region. As you can see, both the area under maize production and the production level have increased significantly since the 1980s. And this has been made possible by the introduction of improved maize varieties, and along with the implementation of effective extension system and availability of inputs to farmers in the sub-region. Maize has also become part of the diet of the people of West and Central Africa, and its importance as a diet has also increased significantly over the years, while the composition of the diet involving millet and sorghum has declined over the years. In the sub-region, there are 4 major agroecological zones, but the dominant agroecological zones are the moist savannas, forest transitional zone, and dry savannas. And when we look at the production in West and Central Africa, the major production zone for maize with high level of productivity and fairly long growing period is the moist savanna, which is shown by the yellow color. But in the forest transitional zone, we have 2 growing seasons, the short and the long growing season, where maize is cultivated from both in the first and the second growing season, which will definitely promote the buildup of diseases and insect pests. Dry savannas represent only, represent a short growing period. we have 4 maturity classes that we would breed for at IITs, extra early and early maturing varieties, which are targeted mainly for the dry and moist savannas, intermediate and late maturing varieties, which are targeted for the moist and also for forest savanna transitional zones. Recent challenges to maize production in Western and Central Africa are 2. And these 2 recent challenges have one thing in common. The first one is the potential threat of the incursion of maize lethal necrosis to Western Central Africa, which occurred in Eastern Africa. And that was called by MCMV introduction from somewhere else. This was the MCMV was not endemic to Africa, but came from somewhere. And fall armyworm, again, is also a pest of North America, and we don't know, how it came to Africa and became a devastating pest. So these 2 recent developments have really something in common. What are the potential factors that may contribute to the spread of the maize lethal necrosis to Western and Central Africa? And when you look at the production zones that I described earlier, the farmers normally plant maize after maize, year in and year out, and that allows really the buildup of plant pathogens and also the populations of insect pests. Some of the seasons are back-to-back, and now we also have some hydromorphic areas, in the moist savannas, where farmers plant maize even during the dry season to harvest and sell green maize to, the consumers. The third factor is a regional harmonization law. When you look at the present regional harmonization laws, which are really required and are important for promoting the growth of agriculture and also the distribution of improved seeds to the various countries. The current ECOWAS harmonization law proposes, it supports a variety which is released in one country can be multiplied and distributed in another country. And with that law, countries that have significant quantity of seeds of that improved variety can transfer the seed to other countries very easily. And with that, there is a potential to introduce some of the diseases and pests. So we should really be aware of utilizing some of these positive developments, policy developments, and try to also plug the holes where we wouldn't really introduce new pests and diseases. When we are also looking at the changing landscape of the seed industry in Western Central Africa, in the past, most of the seed production was limited to each country, and it was quite weak. And now we have regional seed companies, multinational seed companies, even national seed companies are marketing seeds not only in their own country, but also marketing the seeds outside their countries. And there is a possibility of spreading, some of these potential traits, to other countries And once we are aware of the potential of transmission of new diseases and pests, we can put some control options in place to curb the spread of some of the diseases. What are the solutions to prevent the incursion of, for example, MLN? One potential strategy we have been looking at is preemptive breeding against MLN. Why do we have to invest in this preemptive strategy? The MLN hasn't come to West Africa yet, so why do we have to invest on it? You know, that's a question one could pose. And MLN can come anytime due to seed movement through vectors, and all the countries neighboring Central Africa, some countries like DRC already has MLN. It can easily come to Cameroon, and these common borders are potential holes for the movement of MLN. And climate change is also affecting the spread of vectors and also the geographic areas of several diseases, and it may also affect the spread of maize-lethal necrosis. Once maize-lethal necrosis enters West and Central Africa, the countries will require enormous resources to contain the disease, and also the kind of loss the country is going to, the farmers are going to receive from the effect of MLN will definitely have a detrimental effect on their livelihoods and income and their food security. So we believe that preemptive breeding is a good investment, because we will have some products which are ready for multiplication and deployment that would be ready. As you know, breeding is a long-term project, it's a long-term process, and once we have ready products, just in case it comes, we already have a product to tackle it, and that will allow the farmers also to attain their target yields, because they can invest on fertilizer and other inputs to get the yield potential they would like to attain. The traits that we need to adapt maize to MLN trait include durable resistance and also resilience. When it comes to durable resistance, we need to deploy polygenic resistance to the maize-lethal necrosis, which has a broad spectrum resistance which doesn't break down very easily. And we need to also exploit a diverse germplasm to broaden the genetic base. And there are also possibilities of bringing resistance against the two causal viruses together. Once we pyramid that in an individual, there is a possibility of having durable resistance against MLN. And we need to also look at the potential impact of drought in terms of exacerbating the problem of MLN, and combining MLN resistance with drought tolerance is a way to go. When MLN was first discovered, was detected in Kenya, CIMIT organized a large nursery. They also had a screening facility where a large number of elite genetic materials were screened, and some promising inbred lines, including the ones that came from IITA, were identified. And the materials which are shown in red are yellow inbred lines, and the one with CML lines are the white lines, and the last two TZMI lines are lines from IITA. And these materials have been recently being used, for the development of new inbred lines. The strategy that we have used so far is we would like to develop, from the elite germplasm that we have, we used, the source which is adapted to our condition to come up, with a quick inbred lines and hybrids and varieties. We have generated a large number of inbred lines that we are currently advancing, to the next stage. We have also crossed, the introduced materials from, introduced resistant materials from Summit, crossed them to our elite materials, and have generated several lines which are currently being evaluated. We are also looking at the reduction of factors that really weaken the maize plant, that can really accentuate the potential effect of maize lethal necrosis. If you have drought stress, if you have susceptibility to striga, definitely the plants are weak and they can be devastated, by the maize lethal necrosis. So what we are currently doing is we are crossing elite MLN resistant materials and also introduce materials to drought tolerant and also striga resistant germplasm, so that we will have products that combine drought tolerance with MLN resistance and also drought tolerance with resistance to striga. We are also trying to introduce striga resistant, MLN resistant germplasm sources, into provitamin enriched material, so that the products will not be affected, just in case if MLN comes and we have, nutritious germplasm which is cultivated, by the farming communities. They also should be robust enough, to withstand the potential adverse effect of MLN. And the future plan that we have, for MLN is additional good source of resistance, KS 523-5, KS 23-6 were identified as good sources. They are from Thailand. And at Summit, they identified markers and also developed a CASP assay. We have planned to introduce, these inbred lines, to IIT and make crosses and develop MLN resistant inbred lines using, marker-assisted selection. And we have planned to introduce more MLN resistant materials which have been recently identified at Naivasha to broaden and diversify our genetic base. And there are also, inbred lines and germplasm which are resistant to each of the two viruses that are available in temperate and also tropical background. We would like to introduce some of those and pyramid those, in individual inbred lines, so that, we'll have a robust level of resistance in the germplasm that we have at our disposal. The second challenge that to maize production in West Africa is the outbreak of fall armyworm. It was first detected in Nigeria in January 2016. And scientists at IIT use both, the modern tools to identify that the fall armyworm. At the beginning, they thought it was, the commonly known armyworm, Armigera armyworm in Africa, but they realized that it was an invasive species, alien species, which is endemic, in North America and happened to be here. Once it was, the pest was identified, we started looking for control options. In fact, our breeding nursery was so much adversely affected, we really had to do something immediately. So we engaged a number of entomologists that we have, in our program, and they helped us in both identification of a host of insecticides, and we tested them, immediately, quickly tested them individually and also in the various combinations. And finally, we came up, with some insecticide combinations that were effective to control the pesticide. And in the meantime, the entomologists also came up with the best time of spraying insecticides to have an effective control of fall armyworm. When disaster strikes, the breeders, they don't give up and they look for potential resistance, so we have also identified, some tolerant materials from our breeding nurseries, which we are currently looking at. And we have started introducing, resistant germplasm from the USDA ARAs. They have been battling with it for a long period of time, particularly the USDA ARAs at Mississippi State University in Mississippi. They are willing to share their materials, and they promise to send more of their latest materials, for use in our breeding program. But so far, we haven't really come up with a comprehensive short and long-term control strategy to control fall armyworm. We need to look at the biocontrol, resistant maize cultivars, and also the integrated pest management strategy, but we have never had the opportunity to have a very cohesive control strategy to contain this pest. And I hope during our deliberation we address not only the issue of MLN, but also the issue of containing fall armyworm during the breakup groups. Thank you very much.
Thank you very much for that nice overview. Any quick question or clarification, one or two, if it is burning? Salahuddin.
Thank you so much, Dr. Menke, for that brilliant presentation. Now, you say you are already bidding for resistance to MLN. If MLN is not yet in the country, it's not in Nigeria, what are the sources of the isolate that you are using for the screening? And how sure are we that using those isolates of the virus will not also lead to the spread of the virus of the disease in the country?
Yeah, I think that's a good question, and we have been discussing this with colleagues at CIMMYT. CIMMYT has a huge facility at Naivasha, and they have been inviting us, to utilize, the facility in Naivasha. So we are not going to introduce MCMV here, but we will work, with colleagues and screen, our germplasm at some advanced stage of our breeding process. We will screen them, with the support of Summit, at Naivasha. In the meantime, I think Lava can provide an answer. They are also trying to develop a containment facility here in Nigeria. Once that is established, we may also have an opportunity, to screen germplasm. We are still at an early stage, it is not an advanced stage. At that time, we should have, an opportunity to screen it even here. I think Lava can.
Yeah, we are not doing any phenotyping for the disease here. It is all done in collaboration with Simit and Kalro in Nairobi, Kenya. Naivasha, Kenya. So I think the presentation by Dr. Prasanna will clear this aspect. So there is no pathogen outside the disease-affected region. Yeah. So we are not doing any direct phenotyping. It's all breeding, bringing the germplasm, the elite lines from East Africa, do the breeding here, send the germplasm back to East Africa for putting in the endemic sites. No, you don't have to worry about virus being maintained in either experimental facilities or in the greenhouse or anywhere.
Yeah, let me also tell you, we have been extremely careful to get even the embryo lines, that were screened, at Naivasha. The resistant germplasm, we got it from Mexico, not even from Kenya. They were sent, all the germplasm that was sent, from Mexico was screened in Naivasha, but we said, we, according to the rules and regulations of the Nigerian Plant Quarantine Service, we cannot import, seeds from endemic area. So we, in fact, we got the import permit from the Nigerian Plant Quarantine Service, and we were able to get it, from Mexico. Thank you.
Thanks for the clarification. Dr. Edip?
Thank you very much for the presentation. Regarding the fall armyworm, you indicated that you have been using some insecticides and a combination of others. Is it possible to share this with us so we can also take it back?
Yeah, we'll be very happy to share that with you.
Thank you very much.
Yeah. One last question, please.
Okay, sorry.
Yeah, thank you very much. You mentioned that for the control of the armyworm, you are looking at the time of spraying.
Yeah.
I want us to actually discuss this more probably in another session, because I understand it has to be done, I don't know, whether at night.
At the beginning, we really, were in a very frantic mode, and we were spraying, the whole day. Our staff, they were going and spraying. And we realized that, it didn't really make any dent at all. There was no impact. So finally, we discussed, with the entomologists. They came. One of the entomologists stayed in Ibadan for one solid week, studying, the behavior, what time, they come and what time they go, and so on. And they realized that it was in the evening that they come and feast on maize. So that is the time you also go and attack them. So we started spraying in the evening, and it became really effective. Thank you.
Okay, thank you very much. Now I invite Dr. Prasanna to present us an update on the progress in managing MLN.
Okay, good morning, friends, once again. Abebe has made my job easier by presenting many of the aspects related to breeding for MLN resistance, and gave an introduction about the fall armyworm. I will deal with it a little more in depth in terms of how complex a challenge is the maize lethal necrosis as well as the fall armyworm in Africa, and what do we need to do in a concerted fashion to deal with this. As most of you are by now quite familiar, the maize lethal necrosis is caused by a combination of a maize chlorotic mottle virus and any of the members of the Partiviridae. But in case of Africa, it is well established that it is mostly due to the sugarcane mosaic virus in combination with the maize chlorotic mottle virus. The disease was first reported in the Bomet and the Naivasha counties in Kenya around September 2011, confirmed to be indeed the maize lethal necrosis in 2012 before mid-April by Anne Wangai, Peg Redingbo and colleagues from CIMIT. And since then, the disease was spreading very rapidly into Uganda, Tanzania, Rwanda, DR Congo and Ethiopia. This is indeed what the farmer gets because of the disease. She harvested only this much from her previous crop of maize. This is when the disease first appeared. We did a surveillance in Bomet County, and it is really devastating for the poor farmers to lose their entire crop, to sell their cattle, to stop the children from going to school. So it was really a heartbreaking incidents at that time. So this is these are the causal the causal viruses, the MCMV and SCMV, and they can be transmitted by a wide array of insect vectors, including aphids, thrips, and leaf beetles. But what is even more challenging is not just the disease symptoms in the foliar parts, but the ears could be completely barren or even very poor seed set, or whatever seed that is there may not be even edible for even animals. So that's the extent of damage the disease can cause. As Lava pointed out in the morning, MLN or corn lethal necrosis is not a new disease for maize scientific community. It has been reported since 1970s in different parts of Americas. So, but why is it so devastating in Eastern Africa? One, there is undoubtedly a very conducive environment with continuous cropping of maize, especially where there is bimodal rainfall pattern leading to a continuous buildup of virus inoculum. The second major reason is it's not just transmitted by insect vectors. We also often see contamination of the seed, especially the outer layers of the seed like pericarp or in the pedicellin region of the seed. So especially the MCMV, besides the transmission through the insect vectors. The third most important problem here is almost 90 to 95% of the commercial varieties of maize in Eastern Africa are highly susceptible to MLN, and not many sources of resistance were available in the breeder's germplasm when it first broke out in 2011. So we had to make really very intensive efforts to identify and validate and deploy sources of resistance to MLN. Tackling the challenge of MLN is indeed a complex issue. You require not only MLN resistant varieties. I hope it is working, it doesn't. Okay. Developing and deploying MLN resistant varieties, but we also need to strengthen at the same time MLN surveillance and diagnostic capacity, not only in the endemic countries, but also in the non-endemic countries. We also require effective agronomic interventions. We cannot simply go forward with the maize after maize after maize, unsynchronized plantings, but we do need to have a diversified cropping systems that can break the virus cycle, especially with the legumes. The maize legume system is particularly good for breaking the virus cycle here. Phytosanitary testing and safe exchange of germplasm is a very important issue. Besides MLN-free commercial seed production and exchange, I strongly believe that much of the damage has been caused due to contaminated seed that was not detected in the early stages. Now people are much more rigorous in terms of phytosanitary testing, both in Southern Africa as well as in West Africa. The final aspect is how to best manage the insect vectors as well as the other co-hosts of the viruses. So as Abebe pointed out, thanks to the immense generosity of our national partner, the Kenya Agriculture and Livestock Research Organization, KALRO, we have a 20-hectare dedicated MLN quarantine and germplasm screening facility at Naivasha. This facility has capacity to continuously produce the MCMV, the SCMV virus inoculum, and to screen large sets of germplasm all through the year. So this facility is managed by Suresh, who is sitting here very efficiently. We have 3 big poly houses plus several screen houses at the back of it, which enable us to screen for individual viruses. For example, MCMV alone, SCMV alone, whereas in the open field, we have inoculation with both MCMV and SCMV to create MLN. Through this kind of a system, we were able to screen almost 100,000 diverse germplasm entries over the last 3 to 4 years, almost 160,000 rows of germplasm against MLN at Naivasha. By the way, why did we establish this facility at Naivasha? One, there is no commercial seed production anywhere within the vicinity. One side is the Lake Naivasha, which you can see at the back of this photograph, and Naivasha is also the hotspot for MLN. So therefore, we are not establishing this facility in any what we call new territory. So this particular facility is not just for CIMMYT. We do screen large sets of germplasm from public as well as private sector partners. Around 56% of the germplasm screened so far came from CIMMYT, about 20% from the National Agricultural Research Systems, and about 24% from private sector. For the national system, we don't charge them anything. So it is part of our duty to screen their germplasm and to provide them the phenotypes of their entries. Whereas for the private sector, we do recover the cost of inoculum generation and screening. So it is on a cost recovery basis for private sector, and for NARS, even for CIMMYT, it is cost recovery that Suresh is rigorously implementing to make this self-sustainable. Only for the national partners, we don't charge anything. So this facility over the years has developed tremendously. We are very proud of indeed a state-of-the-art screening facility for MLN with very rigorous quarantine conditions. If any of you want to, if you are in Kenya, do visit the Naivasha facility. It's one of the best maintained facilities for any disease. I can very proudly say that. Okay, through all these efforts, what did we achieve? You will be very surprised to know that we already have 9 MLN tolerant or resistant hybrids already released in Eastern Africa, in Kenya, Tanzania, and Uganda. 4 of them already being scaled up and commercialized by seed companies. 2 in Kenya by Kenya Seed Company, 1 in Uganda, it's called Bazooka. It's a drought tolerant and MLN tolerant hybrid, and 1 in Tanzania, that is HP513 by Meru Agro. In addition, 5 more hybrids have been just released in the beginning of this year in Kenya through KALRO. So these are again ready for deployment. In addition, we have 11 more hybrids that are under national performance trials too. So all this means within a span of 4 years, we have resistant varieties not only developed but also deployed. That shows that we are fighting this very successfully and getting the germplasm to the farming communities. If you look at our second generation MLN resistant hybrid, that's on the left, and the first generation one, and look at Duma 43. It is a seed co-hybrid in the center. Completely it is devastated. So against that kind of performance, you have completely clean first generation or second generation resistant hybrids. This is another example. This is a DeKalb hybrid, DK5083, which is showing high susceptibility to MLN at Naivasha. Each and every plant in the open field, each and every plant is inoculated twice. So there is absolutely no question of any disease escape. And compared to that, again, our MLN resistant hybrid. Do you see any disease on the resistant hybrid? Absolutely zero. And there is, when we did this, we do this analysis not just at Naivasha, we then take them to Babati in Tanzania, for instance, for screening against MLN under high natural disease pressure. And when it happens, you can see here again a commercial susceptible hybrid and the resistant hybrid on the right, on the left. So